Now let's look at number 10, the quotient rule. Okay. The quotient rule says, suppose that both f and g are what? What are we going to suppose? What do you think? We're going to suppose that they are both differentiable. At x equals a. That is, suppose who exists? Yeah, f prime and g prime exist. Then the derivative of the quotient. What's a quotient, folks? It's one function, or one expression, in this case one function, divided by another. Okay, here we go. This is our formula for the quotient rule. Okay. It will be the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function all over the bottom function squared. For those of you that are curious where this one comes from, I will derive this in a video that you can watch in the post work. Okay, I'll actually come up with this rule using the limit definition. But really, if you've got the product rule, what can you do with this g of x? You could rewrite it as g of x to the negative 1 power. And once you've learned a few other rules, we could go ahead and just do the product rule on it and then clean it up. Okay, so that's a nice way to see where this one comes from. We'll talk about that in a couple sections. Okay? For right now, we've got a large, complicated formula. Okay? Oftentimes what we'll do is we'll abbreviate this just using the prime notation. We'll write g f prime minus f g prime all over g squared. That just makes it a little bit easier on the eyes. So here's a little ditty to remember this by. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Folks, there's other little ditties out there. I'm not really a big fan of ditties. Okay? Some people say you call this the low one, and you call this one the high one, and then you could say low d high minus high d low, square the low, and there you go. Okay? I find that so hard to remember that I would rather just memorize the stinking quotient rule. But whatever works for you, okay? You have to know this. All right, let's do this problem. Okay? Just like before, we've got an upper function and a lower function. We've got two functions in this expression. Let's call f of x e to the x. And we'll call g of x x to the fourth. So then our quotient rule says that m prime of x, the derivative of the quotient of these two functions, is the bottom function times the derivative of the top. I think I just wrote that. We'll put f prime there. Minus the top function times the derivative of the bottom function. Careful, don't forget that derivative mark on the bottom function. All over the bottom function squared. Folks, quick word of warning. Some people aren't really careful about memorizing the product rule, and they don't memorize it in the exact order I give it to them. That's fine because of the operations that go within the product rule. You got some addition, you got some multiplication, both of which commute very nicely. With division and subtraction, those do not commute well. So does the order matter on all of this? Absolutely. Okay. All right. So let's go ahead and start plugging in what we know. And we'll just put it all in one color. Here's the bottom function, which is x to the fourth, times the derivative of e to the x. What's the derivative of e to the x, folks? E to the x. Minus, right? Minus what?
E to the x.
Yeah, minus the e to the x, the top function, times the derivative of the bottom function. What's the derivative of that bottom function?
3x or 4x to the power of 3.
4x cubed by the power rule. All over x to the 4th squared. Folks, what's x to the 4th squared? X to the 8th. Was that real hard to fix? No, be polite and clean that up. Okay? Careful though, what if I had e to the x squared? What if that had been my bottom? What is e to the x squared? How else could I write that?
E to the 2x.
Yeah, be careful with your properties of exponents. My math lab might say that's the answer. They might say this is the answer right here, and you say, well, this is what I got. Are you both right? Yes. This is the nicer way to put it. Okay. Questions on that? Okay. So that's the quotient rule. Okay. So again, I give you this statement here: the derivative of the quotient is not the quotient of the derivatives. That shouldn't surprise you. If multiplication doesn't work, then absolutely division won't work. Okay. Here you get a nice example of somebody's this is the classic mistake. I see this all the time, right? The top function is x to the 6th. The bottom function is the square root of x. And somebody just takes the derivative of the top over the derivative of the bottom. They forgot all about the quotient rule. They thought they could distribute the derivative over the quotient. So I'll let you guys go ahead and finish up this handout on your own time.